Hello guys, I'm Lewis and today I'll be teaching you the research topic of the specification of AS Psychology AQA Core 1, Unit 1, I think. No, it's Core 1, yes it's Core 1. Right, let's get started then. So, first of all you'll need to know what are hypotheses. So, hypotheses are like they indicate like the what you are like measuring in the experiment, what you're trying to like, what you do in the experiment about what you're testing, and that's basically a hypothesis. There are two types of hypotheses that you need to remember: one-tailed hypotheses or directional hypothesis. Sorry, not hypotheses. These hypotheses that will predict a difference and will predict which group will do better. So let's say students who read textbooks before their exams. So a one-tailed or directional hypothesis for that would be students who read through a textbook before their exam will do better, because it's predicting there'll be a difference and they will be predicting which group would do better. A two-tailed hypothesis, or non-directional hypothesis, sorry, I don't know why I keep saying hypotheses, it predicts a difference, but it does not predict which group would do better. So let's just use the textbook example again. So a one-tailed hypothesis or in non-directional hypothesis for that would be reading a textbook will affect the results. That's basically a two-tailed hypothesis. Next, let's go on to variables. Variables are just anything that changes in the experiment and does not stay constant. So there are a few types that you need to remember. Firstly, there's independent variable, which is a variable that is being changed by the researcher. So it's being changed intentionally. So yeah, that's the independent variable. Dependent variable is the result from that change of the independent variable, so the variable that you are measuring in your experiment. The operationalized variable is the units that you are using to measure the dependent variable. So let's say how the independent variable affects the dependent variable, like length for instance, and then the operationalized variable would be centimeters, millimeters, or whatever you're measuring the dependent variable with. Lastly, there are extraneous variables that you need to remember, and these are variables that change the experiment that are not intentional. So there are a few that you've got to remember. One is situational factors or environmental factors. So let's say you're doing a field experiment and, well, your participants are exposed to the environment, so light conditions, weather may affect the results, and that would be considered a situational factor or environmental factor. Lack of standardization, so this is when you do like just repeat the tests that you've been doing with the participants before, and obviously if you do something more than once you're increasing skills, so that's basically lack of standardization, because you're not using different tasks for different parts of the experiment. You're just using the same task, and that's obviously going to affect your results. Participant variables, these are variables that are about your participants. So let's say your participant has blonde hair, and your study is like trying to find out how people with blonde hair, I know it's a really bad example, react to fire, for instance. Well, you can't really use that participant since did I just say blonde and blonde? Never mind. Well, if they've got a different hair colour or whatever, that's obviously a participant variable that will affect the results, so you can't use that participant. Demand characteristics, this is when the participants are aware that they are in an experiment and they may behave differently, since they're being observed by researchers, and they might try to guess the aim of the study, which can really mess things up for experiments, and they will be considered demand characteristics. Lastly, research bias. This is basically like a researcher is confident that their study is correct, and they may design the experiments so it will be the case of that their theory or predictions are correct. So yeah, that will be considered as research bias. Also, they can form hypotheses that are going to be wrong and predict changes that they want. That's also another case of research bias. So there are variables. We've got controls. Psychologists employ controls, obviously to reduce the amount of extraneous variables in their experiments. One control could simply be the same type of participant in an experiment. So, using the example before, make sure that all the participants have blonde hair and none of them have ginger hair. Also, to indicate like extraneous variables early before you start the actual test, the researcher may conduct a pilot study, which is just a small version of the test, like a small scale version of the study. So, and they'll use normal participants still, and they will indicate the problems so they can be addressed before the actual study starts. Validity. Validity is just about how valid your results are. So there are two types of validity, internal and external. Internal has the study measured what it was intending to measure. There are two types of internal validity: face validity and concurrent validity. Face validity is do the results look right? So let's say just done an experiment on interference from memory, and this is one of the pecs actually, one of the advantages of the studies, if I can remember correctly. So if a study has face validity, it feels right, you've experienced it before and the results link to what you've experienced in real life, so that'd be considered face validity. Concurrent validity is, do your results link with other studies? So let's say you've done a study that millions of people have done before. Are your results the same as the other guys' studies? External validity. This is can the results from the study be generalised for further situations? There are three types. There are ecological validity, population validity, and temporal validity. So ecological or ecological, or however you want to pronounce it. This is to do with real life tasks and stuff. So let's say your experiment was conducted in a lab. That's going to lack in ecological validity, because usually tests and tasks that you're doing in a lab really don't link to real life situations. So that would kind of fail and lack in ecological validity, because it's not really to do with everyday life. Conversely, in a field experiment, there'll be high ecological validity because the participants are not aware that they are being observed, and therefore the tasks will be related to real life situations. Population validity is concerned with the participants that you use in your experiment. So let's say you only use one type of population, so students that we use in Zimbardo's prison experiment. That has low population validity because they only use students, and behaviour may be different for other types of population, such as old men, kids, parents, etc. So, if a study is being done multiple times for different types of people, it will have high population validity. Temporal validity concerns how old the experiment is. So, if an experiment was done very recently, it would have high temporal validity, since it's more up to date, basically. So yeah, it's just easier to link in to real life, to be fair. And if an experiment was done ages ago, then it would have low temporal validity. Yeah, and that's validity, basically. Moving on to ethics. Ethics are anything that's ethical about the study, so there are a few types of ethics that you need to remember, so listen up. One is informed consent. This is when the participants are not really sure what's going on in the experiment, and therefore can cause participants to be scared because they don't know what's going to happen next and things like that, and it's not really ethical, is it? So the participants' point of view of this is whether if they want to take part in the study or not. So having high informed consent gives the participants more choice and more assurance, you could say, of being part of the experiment. A researcher's point of view, though, is it will cause a demand characteristic since the participants are more aware of what's going on in the experiment. Ways you could address this issue is you could formally agree with the participants before the experiment, or have a debrief at the end of the experiment. Deception. This is when researchers are withholding information or lying to the participants about the study. Participants' point of view is it prevents availability for informed consent that we just talked about a minute ago. Researchers' POV point of view may cause demand characteristics again. Solutions: you could seek permission from an ethical committee, presume consent, as that's called, or have a debrief after the study again. Right to withdraw. This is when the participants feel like they cannot leave the experiment because, well, sometimes there is a pay involved, like, so you get paid to take part in the experiment, basically. So if you are being paid for taking part in the experiment, then you might feel that you cannot really leave the experiment because, don't know, you might you will not get paid. That's what they might feel like, to be fair. So that's basically right to withdraw. And in Milgram's experiment, they wouldn't let the participants leave at all, so that's another right to withdraw. Participants' point of view is maybe unable to leave the experiment because they might ruin it, and they might not see the rewards that they are going to get given after the experiment. The researchers' point of view is there might be a loss in participants because some studies cause anxiety, and that will make the participants want to leave, so we'll have to find more participants. Solutions: assurance of awards before the studies. You could say to the participants that you will get your reward even if you leave the study, which will make them stay. And that's basically for solutions. Protection from harm. So if your study may cause psychological or physical harm, and that's obviously unethical, so they need to be addressed. Participants' point of view is, well, they have no desire to be harmed, and researchers' point of view is it's impossible to predict risks inside the experiment/study. Solutions: you could avoid risks that are greater than those in real life, and if anyone gets hurt in the experiment, you could stop it immediately and seek medical attention. Confidentiality: this is when participants need trust of the experiment or researcher securing their information that they are gathering. So yeah, that's basically it, the trust between the researcher and the participant, the participant's information that researcher has. Participants' point of view is data protection acts make confidentiality a legal right, and A researcher's point of view is detailed study might lead to participant identification. Solutions: make sure the participants have no names, so just give them a number. So there's no real information going out there, and it's a bit harder to identify which participant it was. And another one is store the information securely, so no one can't get their hands on the participants' information. Lastly, we have got privacy, so a person's right to control the flow of personal information, their personal information about themselves. The participant's point of view is people have an expectation of privacy, so they feel like they should control their private information, and that's completely true. Yes, that is right. Yeah. And a researcher's point of view is may cause demand characteristics and change of behaviour from participants if they're aware of being observed, which is basically demand characteristics. Solutions: do not observe without consent, or maintain confidentiality. Basically the solutions. Types of experiments. There are a few types of experiments that you need to remember. Lab experiments, I've mentioned these before. It's when the participants are in a lab, therefore a controlled environment. So there are reduced extraneous variables, so the strengths of this type of design of experiments. There are high levels of control inside the experiment, therefore reduced extraneous variables, and it's easier to repeat the experiment. So, well, lab experiments usually have a procedure, they're not like field experiments, which I will explain in a minute. So it's easier to repeat the experiment, which will increase the reliability of the results. Weaknesses: the research is very artificial, therefore low ecological validity, since the tasks will not relate to real life, since they're artificial. There's a high chance of demand characteristics, so therefore when you're in a lab you obviously know that you're being observed, and the participants may change their behaviour to impress a researcher. And there's a huge problem with ethics inside lab experiments, because there's a lot of confidentiality, which is quite bad. Field experiments: this is when the participants are not aware that, well, mostly are not aware that they are being observed, and it's not in a lab. So the strengths of field experiments are high ecological validity, since the tasks in field experiments are more to do with real life, and there is less chance of demand characteristics, since the participants are less aware that they are being observed. Weaknesses: there are low levels of control, so since it's not a controlled environment, therefore it's hard to control, and it can cause a lot of high levels of extraneous variables, which are really not good. And again, there's a huge ethical problem, since participants have no idea that they are being observed, and there's a massive invasion of privacy, which is not good. And lastly, quasi experiments. These are like a mixture between the two, to be fair. So the strengths of quasi experiments are there are not that many ethical issues, since the research and the participants get along, and it enables the psychologists to study the real problems. Yeah, that was really badly explained, but it's quite late at night, so. Weaknesses: there are no controls over extraneous variables, and it's hard to see which variables will affect which aspects of the study. and it's hard to examine rare events since they are obviously infrequent, hence the word rare. And yeah, it can be quite hard to like set up a quasi-experiment, and there is still deception and confidentiality in quasi-experiments, so yeah, it's never good. That's it for part 1. Make sure you subscribe, and more psychology and A-level revision coming soon. Thank you for watching, guys. See you later.